Okay, so we're going to be starting Unit 6 today. So for Unit 6, we're going to be leaving out a few of the sections just because this stuff's not crucially important that you know for a calculus. But they all will be on my Google site if you want to go see what they are. So guys, there is a formula sheet that's posted, so when I mention a formula sheet, that's the formula sheet I'm talking about. So we are going to actually do this warm-up today. Before I do the warm-up, so if you look at the notes where it says basic trig identities, so these are the trig identities that you've been using when you were working with your right triangle trig and when you were working with the unit circle. So cosecant, we know, is 1 over sine. Secant, 1 over cosine. This one we don't use that much, but cotangent is 1 over tangent. Sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. So when you were doing those reciprocal trig functions, so that like sine goes with cosecant, it's just you can always rewrite it as 1 over its reciprocal trig function. The two that you're going to use the most are tangent is sine over cosine, so think about in your unit circle y over x, and cotangent is cosine over sine, so x over y. You kind of already know these. These would need to be memorized. These will not be given to you on any type of formula sheet. So I'm going to go back to the warm-up. So these are the things that you should have covered a little bit in Math 3, but we want to simplify this to one single trig function. So for the first one, we have cotangent x times sine x. Okay, so our goal is to get this to one trig function. So what you want to do is anything that is sine and cosine, you want to leave it alone. If it's not sine or cosine, you want to rewrite it in terms of sine and cosine. So cotangent, if you remember, is x over y, which is cosine over sine. So we're going to rewrite that. And then because this one's already just sine, we're going to just keep it as sine x. So here, since we have sine in the denominator and numerator, those can cancel out. And all we're left with is cosine x in the numerator, which is just cosine x. So that's written as one trig function. Okay, so looking at number 2, secant x times sine x. Okay, so we want to rewrite secant x. So secant goes with the trig function cosine. So secant is the same thing as 1 over cosine x. And then we're going to keep sine x like it is. So this time nothing cancels, okay? But we have sine x left in the numerator over cosine x in the denominator. Well, sine over cosine is tangent x. So we rewrite that as one trig function as tangent x. And then the last one on the warm-up here, we have tangent x times cosecant x. So neither one of these are sine and cosine, so we're going to rewrite both of them. Tangent, remember, was y over x. So that's sine x over cosine x. And then cosecant x goes with sine, so it's 1 over sine x. Okay, because we have sine in the numerator and in the denominator, we can cancel those out. So we're left with 1 in the numerator over cosine x. Well, 1 over cosine is equal to secant x. Okay, so that covers your warm-up. Like I said, this is stuff that you should have done in Math 3, but if you didn't, it's okay. These are just the basic, like rewrite in your anything that's not sine or cosine in terms of sine and cosine, and then simplify. Okay. All right. So moving on. So this is called fundamental trig identities. So this is the slide that we already looked at. So these trig identities here are the ones that we just used to do the one. Okay. These Pythagorean identities. So Pythagorean identities comes from Pythagorean theorem. They are super important for you to know. You will use these a ton in calculus, and we'll use them a ton for this unit. These you would have to memorize. They would not be on any type of formula sheet, and they would never give them to you. So hopefully you've seen the top one. So cosine squared theta plus sine squared theta is equal to 1. Okay, this one is the most important, this one's the most common that you will use the most. But cosine squared plus sine squared is equal to 1. The other two are also common, but if you know this one, then you can, there's a trick to know the other ones instead of just memorizing them. So what you can do, if you take cosine squared theta plus sine squared theta equals 1, and if we divide this whole thing by cosine squared theta, so watch what's going to happen. We have cosine squared divided by cosine squared, that would just be 1, plus sine squared divided by cosine squared, well, we know sine over cosine is tangent, so this would be tangent squared theta, equals, and then 1 divided by cosine squared, well, we know 1 over cosine is secant, so this would be secant squared theta. So take a look at your second formula there, and that is the formula we have here. So we knew the first one, we could figure out the second one. So then we're going to do the same thing to get that last formula. So this time, instead of dividing by cosine squared, we're going to divide by sine squared. So watch what happens. You know, cosine divided by sine is tangent, so this is going to be tangent squared, we know cosine divided by sine is cotangent, so it's going to be cotangent squared theta, plus sine squared divided by sine squared will just be 1. And then we know 1 over sine is cosecant, so this is going to be cosecant squared theta. So if you look, that is the third formula on that Pythagorean identity. So these are all called Pythagorean identities, just different relationships between the different trig functions. And you do have to make sure that you know this. Okay, and the last thing for this video, we're going to use these trig Pythagorean identities and the trig functions to solve a few problems. So, if we look at the first one, we're trying to find sine theta, and we're trying to find cosine theta. They tell us tangent theta is 5, and they tell us cosine theta is greater than 0 or positive. Okay, the first thing that we want to do is I want to work with our sines. So there's a little trick to figure out what trig functions are going to be positive. So think about this as your unit circle. This is quadrant 1, 2, 3, 4. The little saying is all students take calculus. Okay, it goes in order. A, S, T, C. The letter stands for which ones are positive. So like in the first quadrant, all trig functions would be positive. Second one, just sine would be positive, which would also mean that cosecant would be positive. The third one, tangent's positive, which would also mean cotangent's positive. And then the C stands for cosine is positive, which would also mean that secant is positive. So with the information I'm given here, we know tangent is positive. Okay, that tells us this here. And we know cosine is positive. So if more than one trig function is positive, that means this would have to fall in the first quadrant where they're all going to be positive. So when we finish, sine should be positive and cosine should be positive according to what we just figured out here. Okay, so we don't have to worry about negative. Okay, they are giving us tangent. And I'm going to use my Pythagorean identities. I'm going to go back to my Pythagorean identities just so you can see them. So with these Pythagorean identities has tangent in it, so that would be the second one. So I'm going to use the second formula, 1 plus tangent squared theta is equal to secant squared theta. Okay, and I'm going to just plug in. So we have 1 plus tangent, it tells us it's 5, so that's going to be 5 squared is equal to secant squared theta. So this is 25 plus 1, so 26 equals secant squared theta. So if I take the square root, secant theta. Now, here's where this says. Secant theta is technically going to be plus or minus the square root of 26. Okay? Now, because we decided that all the trig functions are going to be positive, we can cross out the negative. But this is the point where you have to decide if it's going to be positive or negative. So secant is going to be positive square root of 26. Okay, it didn't ask us for secant, but it asks us for cosine. We know cosine is the reciprocal of secant. So that means cosine has to be 1 over the square root of 26. And we know it has to be positive according to this, and we figured out they're all going to be positive. The other trig function that we want to figure out is sine. Okay, so because we know tangent and we know cosine and we need sine, the formula, now there's other formulas that you can use, but the one that would be the easiest to use is we know that tangent theta is equal to sine theta over cosine theta. So we know that tangent is 5. We're trying to find sine theta, and we know cosine theta is 1 over the square root of 26. Okay, so in order to solve for sine, I'm going to cross multiply. This will be 5 over the square root of 26 is going to be equal to sine theta. And remember, we said it was supposed to be positive, so it's going to be positive. Okay? Alright. And then for our last problem in this type, we want to find sine and tangent. It tells us cosine theta is 0.8, and it tells us that tangent theta is less than 0. So I'm going to figure out my sines first. So it's all students take calculus. Okay, we know that cosine is positive, but we know that tangent is negative. So because cosine is the only one that's positive, we know we're going to be in this fourth quadrant here. So the only two trig functions that are going to be positive is cosine is going to be positive, and its reciprocal secant is going to be positive. Everything else is going to be negative. So my answer for sine should be negative, and my answer for tangent should be negative when we get those answers. Okay. So I'm going to go back to my Pythagorean Identity. So they're giving us cosine, so I'm going to use the top one, cosine squared theta plus sine squared theta equals 1. Okay, cosine theta is 0.8, so it's going to be 0.8 squared plus sine squared equals 1. 0.8 squared is 0.64. And then if I do 1 minus the 0.64, that'll be 0.36. Okay, so at this point we're going to take the square root. The square root is plus or minus the square root of 0.36, which is 0.6. Now, it can only be either positive or negative. It can't be both. So we know that sine is supposed to be negative. So my sine theta is going to be negative 0.6. Alright, and then to finish this up, we need to get tangent. So we know that tangent theta is sine over cosine. We're trying to find tangent theta. Sine, we just found, was negative 0.6. And cosine, that was the original problem they gave us, was 0.8. Okay? If you have a calculator, you can type it in. If not, this would be just negative 6 over 8, which will give us negative 3/4. And if you remember, tangent theta was supposed to be negative. Okay, we said that up there, and it is negative, so that's going to be our answer. So guys, for these, you're pretty much going to use a Pythagorean identity first, and then a lot of times you're going to use this tangent equals sine over cosine to finish off for the last part.